This is Algebra 2, Unit 6, Lesson 12, using the focal length of a parabola. Now, we know that the standard form of a parabola is y equals ax squared plus bx plus c. And how can we use this formula to find the focus and directrix? Well, we talked about that yesterday when we did figuring out the values using the distance. So we know the distance from the vertex to the focus, this distance right here is called p, which is the focal length. And we know the distance to the focus is equal to distance directrix. So the distance here, focal length here, is the same as it is here, because the vertex is halfway between the focus and the directrix. All right, now let's apply what we did yesterday to this problem. We know if we have any point on the parabola, it will be equidistant from the focus, and it will also be equidistant from the directrix. So let's see if we can use that fact to figure out an equation for the parabola and for the focal length. So first of all, we need to know what the coordinates of the focus would be. Now, if P is my focal length, and we want to assume that the vertex is at 0, 0, because that's an easy one to use. So we're going to use 0, 0 for my vertex. And xy is going to be the point. So we want to figure out what this distance right here is, so we need to know what the coordinates of the focus would be. Well, if this is point 0, 0, and this distance is p, this is increasing by p, but it's still on x equals 0, on the axis of symmetry. So the focus length will be 0, p, so go from 0 to p. So the distance from here to here is p, so it'll be 0, p. All right, now just for argument's sake, this is going to be 0, p. The directrix would be this way from p units away from the vertex, but it's below it. So the equation of the directrix will be y equals negative p. So the y goes down, it would be y equals negative p. All right, so what we need to figure out is what the distance is here and what the distance is here. So if we know those values, I can take the distance formula and figure out what this distance d is. We said this was 0p. We can figure out the equation, or excuse me, the distance from the focus to the xy. So distance from xy to the focus is equal to the distance from xy to the directrix, because any point on the parabola is equidistant from the focus and directrix. So using what we did yesterday, we can use the distance formula. All right, so the distance formula from here to here is the square root of delta x, the difference between the x's, x minus 0 quantity squared, plus y minus p quantity squared. That would be the distance from the focus. That would be this d right here. That's going to equal the distance here. All right, now imagine that this is your point y. The x-axis is in here. Let me draw the x-axis in so that we have it. I'll do it in blue so you can tell where it is here. This is the x-axis. Oops, because the vertex is at 0, 0, remember. Okay, so if your vertex is at, this is the x-axis. The vertex is at 0, 0. So that means the distance from here to here is y, because you're going over here and then up y on the x-axis. However, but this goes down farther, a distance of p. So what would be the distance from here to here? It would actually be y plus p. That would be the distance. So the distance from xy to the directrix will be y plus p. So now we can solve this equation. I can simplify this. I want to get rid of the square root, so I'm going to square both sides. And that gives me, whoops, that's going to cancel out the square root. That's going to give me x minus 0 squared is just x squared, plus y minus p quantity squared equals y plus p quantity squared. Ooh, that's a 2. So, squaring y minus p squared, remember y minus p squared is actually y minus p, which is y squared minus py plus p squared, which gives me y squared minus 2py plus p squared. And we do the same thing with y plus p. The only difference is going to be, it's going to be plus and plus in the middle. It's going to be y squared plus 2py plus p squared. All right, now we want to solve this for y. Well, let's notice what we get here on the sides. Y squared is the same on both. They're going to cancel each other out. P squared is going to be the same on both. So that gives me x squared minus 2py is equal to 2py. Move the y's together, so we add the 2py. We get x squared is equal to 4py. And solve for y, divide by 4p. We end up with the equation y equals 4x squared over 4p. So that would be the equation of the parabola in terms of p. Now, how is that going to help us dealing with the focal length? Remember, p is the focal length. We just found that y is equal to x squared over 4p. Now, let's compare this to the form of the equation y equals ax squared plus bx plus c. Well, this is x squared, so isn't this really a 1 out in front? So couldn't this actually be y equals 1 over 4p x squared? So this right here is actually the a value of the equation. So we know that a is equal to 1 over 4p based on what we just did. So could I solve this equation for p? Sure I could. A is equal to 1 over 4p. Cross multiply, you get 4pa is equal to 1. And then divide by 4a. And we get p is equal to 1 over 4a. So this gives me the equation of the focal length. The focal length formula is p equals 1 over 4a. So if you know the a value of the equation, you can use it to find the focus and directrix. So what you have to do with that, using this formula, first determine whether the parabola opens up or down, and then you'd have to add or subtract whatever you find for p to the y-coordinate of the vertex, and you would find that out. So let's see how that works. So we are going to use the focal length to find the vertex, focus, and directrix of the parabola whose equation is given. Now, it's very helpful when you do these to draw yourself a little sketch. So let's take a look at y equals 1/16 x squared. All right, so it's just x squared, so we know in general that's going to be just a parabola that has a vertex at 0, 0. So we know the vertex is going to be 0, 0. So the vertex is going to be at 0, 0. Now, which way is this going to point? Well, it's positive here, so this is going to be pointing up, so it opens up. So just to draw myself a quick sketch, 0, 0 is my vertex. It's going to open up like this. Okay, so this is going to be at 0, 0. Okay, so since this is opening up, the focus is above here somewhere, and the directrix is down here somewhere. Okay, so we know, let me do the directrix in a different color. So the directrix would be down here. That's my directrix. So we need to know what p value is right here and right here to figure out what the focus and directrix is. So the formula we just came up with, we said p is equal to 1 over 4a. We just figured that out. What is my a value in this problem? Well, p equals 1 over 4a. A is 1/16. That is a. So this is 1 over 4 times 1/16. And 4 times 1/16 is 4/16 or 1/4. So it's 1 divided by 1/4. When you take 1 divided by 1/4, basically use the reciprocal, p is going to equal 4. So that means my focal length from here to here is going to be 4. So my focus, since this is pointing up, I know the x-coordinate is going to be the same. It's still going to be 0. And then my y-coordinate is going to go up by 4. So it's 0 plus 4. So my focus is actually going to be at the point 0, 4. So that's going to be my focus. All right, my directrix, since this is pointing up, is below the parabola here. It's telling you it's down here. So it's going to be 4 units below the x-axis. Well, if you're 4 units below the x-axis and parallel to it, your directrix is going to be at y equals -4. So the directrix will be y equals -4. So that's how you would use the focal length. So when you're doing this, you had to use y minus p to get this. So the y value was 0, 0 minus 4 is -4. So your focus is at 0, 4, your directrix is at y equals -4. Now, what if we had y equals negative 1/4 x squared? Again, this is going to be a parabola that has a vertex at 0, 0, because it's just x squared. But since this is negative, what's that going to do to the parabola? It's actually going to open down. It opens down. So, if I do my sketch of my parabola, like so, all right, 0, 0 is going to be my vertex, but it's going to open down like this. Now that means that my focus is going to be here, and my directrix is actually going to be above the parabola up there. It's going to be up here somewhere. So we need to figure out what this is going to be here for the focal length, and this is going to be the focal length. Now notice here that the a value is negative. So since p equals 1/4a, that means that negative a will equal negative 1/4p. So when we deal with that and solve that, that's going to give me p is equal to negative 1/4a. If you cross multiply and solve all that. So we end up with negative 1, because it's negative, it's going to be negative 1/4a. So basically you just make this negative. All right, now let's plug in our a value. Our a is negative 4, or negative 1/4, I'm sorry. So this is negative 1/4 times negative 1/4. 4 times negative 1/4 is negative 1, and negative 1 divided by negative 1 is positive 1. So my focal length right here is 1. So if my vertex is at 0, 0, notice here, because this is pointing down, my focus is down here. So my focus for this one, I actually have to subtract. So I have to take 0, but then subtract 1, 0 minus 1. So my focus is going to be at 0, negative 1. And my directrix, you have to go up 1, so my directrix will actually be at y equals 1. So the vertex is at 0, 0, the focus is at 0, negative 1, and the directrix is at y equals 1. All right, let's try this next one. We have this one a different form. Y equals negative 1/8 x plus 1 squared plus 4. What's my vertex? Well, remember your vertex is actually your h and k. This is your h, this is your k. So the vertex on this one is going to be at negative 1, 4. Which way is this going to open? It's actually going to open down, because it's negative a. This is negative. So if I do a quick sketch here, here's my sketch. Black. All right, so here's my sketch. My vertex is at negative 1, 4, so it's probably about there somewhere. And this is going to open down. It's going to open like this. So my focus is actually going to be here, and my directrix is going to be up here. So I need to know my focal length so I can figure out where everything is. Okay, so remember my focal length is here and there. That's my p. And since this is opening down, it's going to be p equals negative 1/4a, because it's opening down. So a in this case is negative 1/8. So this is 4 times negative 1/8, which is negative 1 divided by negative 1/2, and negative 1 divided by negative 1/2, so p is going to equal 2. So my focal length is 2. So if p is 2, and this is at negative 1, 4, my focus is actually going to be negative 1, 4, and then subtract 2 from here. So it's negative 1, 4 minus 2. So it's going to be at the point negative 1, 2. So my focus is going to be at negative 1, 2. And my directrix will be 2 above here, so I'd have to take the 4 here and add 2, so that gives me a directrix of y equals 6. So that puts me right there. Okay, let's do one more. Y equals 1/2 x minus 1 quantity squared. Well, the vertex for this one, according to our formula, this would be the h, would be 1. What's the k? Well, this is actually plus 0, so this is going to be a vertex at 1, 0. Now, when I sketch this, I'll leave the same axes, and my vertex is at 1, 0, it'd be right there. Which way is it going to point? It's going to point up. All right, we'll finish this one in class, and we'll finish the rest of the notes on the next lesson. See if you can finish this one out and get it to work.